He told me 1 hour, 8 slides at most.
How long was the talk?
1 hour. Sometimes I have troubles when people, fight because they say, oh, you cannot be completely theoretician, you cannot be completely applied or whatever. Like, yes, you can do whatever you want, that's why you do research.
Hi everyone, Charles here for ML Papers. And today we are very fortunate to receive Pierre Alquier, a French researcher specialized in PAC-Bayes Bounds within the field of statistics and machine learning. So he's definitely a big expert in the field. He's what we call a rock star, in our words, and he's also very modest. And today he's going to enlighten us on what he's doing, his topic, and also what researchers do in real life, and various questions like how do we learn machine learning, how do we improve, how do we do research, and all those questions that you guys ask me on many social media platforms. Now, Pierre, thank you very much for joining us today.
Hi.
For the viewers who don't know you, could you please introduce yourself first?
I grew up in the south of France and I wanted to study physics actually in high school until I realized that I was really not good at it and that the logic of math was, fitted my brain in a better way actually. Maybe a little randomly I ended up at NSAE in Paris studying statistics, econometrics. I met the right person and they advised me actually to study the application of statistics to machine learning. So I did my PhD thesis with Olivier Catoni, both at NSAE and at Université Pierre Curie, on PAC-Bayes Bounds in machine learning actually.
Why PAC-Bayes Bounds? Where does this idea come from?
I was young, I was not yet completely sure what I wanted to do, and Olivier Catoni actually was working on a PAC-Bayes Bounds at that time, and he proposed the topic like a research direction for the PhD thesis, and I was super enthusiastic about that. So of course there's a part of randomness there. Like I met a few professors, each of them had like a research proposal, and I was not aware of PAC-Bayes Bounds at the time, but then I was like, wow, okay, it looks super interesting, I want to do that.
I see. And the topic like brought you what you wanted, but it could have been a different topic, and you picked this one, which was very fortunate because you're really doing extremely well on this topic.
I mean, honestly, of course, there's always a part of randomness in what you decide to study, right? It's what you like, but it's also the people you meet and what is also explored by the community at that time. If I had come like 50 years before, there would not be so much computer science around, so probably the topics in applied math would have been quite different.
I saw that you had previous experiences in many countries.
After my PhD thesis at NSAE, first actually I had a very quick, very short-term position actually at Dauphine in Paris also, and then assistant professor position in Université Paris Diderot. The professor there were, like after your PhD, you might still need some guidance, etc. And the professor did a super job actually to protect us from teaching overload and to guide us actually, so that was cool. But it was exactly the same community than the people I was working with during my PhD. After that I moved to Dublin, so I spent 2 years in UCD in Ireland. It was completely new community, even though it was not that far, and actually I learned a lot also from the people I met. And after that I went back to NSAE, so that was like almost 10 years after my, my PhD, okay, and I was a professor there. Yeah, indeed, after that, I moved again to Tokyo. I spent 3 years in Recon AIP. Last year, I moved from Tokyo to Singapore at ESSEC, a French business school, but they have a new campus in Singapore since a few years.
In order to get to know you a little more, I'm going to give you 50 seconds and ask you very simple questions, yes or no, or binary or ternary choice. What is better, machine learning theory or applications?
We need both.
Frequentist or Bayesian statistics?
Both are the same.
Are you sometimes scared of running out of ideas?
Yes.
Will you still do research at the age of 75?
I don't know.
Do you sometimes regret being a researcher?
No.
Do you consider yourself more as a professor or as a researcher?
Both.
Did you ever fall asleep during a research talk or at a conference?
No.
If you can decide where the next big machine learning conference will be, which of the following three would you pick? France, Morocco, or Singapore?
Singapore.
What is the best YouTube channel to learn about machine learning?
ML New Papers.
That's it. What does your normal day look like as a researcher?
Optimistically, the normal day would be that I arrive at work, I first get some coffee at the coffee machine, and then I sit at my desk and I do research. Unfortunately, not many days start like that, so I would immediately start by checking my emails and seeing that I have many requests to review papers from associate editors from various journals, and then I have actually various, I am now an associate editor myself, so I have messages from reviewers saying that they're going to be late. Unfortunately, all these auxiliary tasks easily take a lot of time. Usually, I like to start with these tasks, and then when I'm settled in, when I feel well beyond my desk, at some point I really focus on more important stuff like research.
What percentage of your time do you dedicate to research or to teaching and reading research papers, for example?
Reading research papers, it takes a lot of time, but I consider it as part of research, actually. It's not the same as when you're writing stuff yourself, but it's still part of research. Teaching, of course, I don't choose. It depends on the institution you work in, right? I try, ideally, to read research papers or textbooks every day. Even when I don't have time, because I have too much teachings to prepare, too much papers to review, and I don't have time to write my own research, I try to keep time to read research papers every day.
So that's a great habit, even at your level, to keep reading research papers every day.
Yes, and also I'm lying. I'm not doing it every day, actually, but I try to do it every day. Okay.
I see. You mentioned your research. Could you tell us more about it? So you're specialized in PAC-Bayes Bounds.
PAC-Bayes Bounds are one of my topics. I wrote recently more papers and a tutorial on PAC-Bayes Bounds, but I really like to say that my research is more generally on statistical machine learning theory. So everything that statistics can bring to help machine learning. PAC-Bayes bound obviously is one of them. It's a subfield, I should say, of generalization bound. Generalization bound are upper bounds in a mathematical sense. And the idea is that you want to get guarantees on how machine learning algorithms that you train on data will generalize on future data, future tasks they have to solve. So you can get actually numerical quantification of this through generalization bound. There are various kinds of generalization bound coming from various research communities, and PAC-Bayes is one of them. It's slightly connected to Bayesian statistics. It's also connected to information theory, to minimum description length principle, etc. And the idea is essentially that you quantify the generalization ability of your algorithm through complexity term that depends on the prior distribution. So essentially, this bound relies on these tools to build generalization bounds. Statistical machine learning theory is a theory of why machine learning works and how to improve the algorithms. Sometimes I have troubles when people, fight because they say, oh, you cannot be completely theoretician, you cannot be completely applied or whatever. Yes, you can do whatever you want, that's why you do research. What we should keep in mind is that this theory is developed for an application. So you should keep the application in mind and know that your theory is developed to explain something that happens in practice, actually. So if you don't like that, then probably you should do pure math.
And so for a more application perspective, what kinds of applications can we see from those PAC-Bayes bounds theory, for example?
Essentially, any application of supervised learning, right? So classification, we have all the examples in the textbooks, in the history, like classification of emails, classification of images, and then thus pattern recognition, etc., and classification of disease based on DNA or this kind of thing. So actually, all the applications of supervised learning are situations where you can use a PAC-Bayes bound, first to get actually a generalization guarantee, a generalization bound on the algorithm that you use, and then also maybe the theory can guide you to better calibrate your algorithm when you're actually training your machine. Machine learning in the 80s and the 90s actually, the statistical learning theory was developed and was far ahead of practice in the sense that many of the practical ideas came from the theory. Vapnik developed Vapnik dimension, and then 20 years later, Vapnik developed supervector machines, and we could understand why the Vapnik dimension in the case of supervector machine was controlled, etc. And then it leads to the development of new algorithms that were state-of-the-art at that time. And now it's the opposite. Practice deep neural network was super well, and the theory is 15 years beyond, trying to explain what is happening there. I want theory to lead the way again, because I think that theory can, shed light on practice. And I would like to come back to the previous situation, if possible, because for me, it's the role of theory to guide practice and not the opposite. And I don't know if it can happen, by the way. It might just be, also me being nostalgic of a different era that might never come back, but I would like that.
How do you find research topics and solutions to those problems?
My answer is that I don't have an answer. So when I was a student, I was relying, obviously, in the beginning on my PhD advisor for ideas. And then after that, I started to develop a few of my projects very slowly. And I attended conference, I met people, and suddenly one would say a thing that would give me an idea for something else, etc., etc. Many occasions, something comes, from a talk I see or from a random meeting or whatever. So I would say just be open to, to everything, to the talk you might attend, the seminars, the conferences, etc. It's always nice. You have a friend working on something different. You see if you can collaborate with this friend, and then you do something. That was actually my first post-PhD project.
So really based on collaborations and discussions?
Based on randomness, really. Like, I don't have an idea, and the next moment I have an idea, and it might be from a collaboration. At some point, I was working a lot on the lasso also. I have many papers on the lasso, sparsity, etc. And then one of my colleagues was doing a sparse estimation in quantum physics, actually, inverse problem in quantum physics, where you would have some sparsity of the eigenvalues of some matrices, and it's used by physicists to reconstruct quantum states. Then we worked on it because this person was around, and I was able to help because I knew things on the lasso, whatever, not because I was a specialist of quantum physics. So you can work on many possible research directions because everything is connected, and because even if you have one very narrow specialty, people might need your expertise, actually. And then it's nice to be open because you can learn new topics, and suddenly I've seen people who would learn a little new topic like that and suddenly switch, and a few years later become complete specialists of this new topic. You live your life, and after 20 years, you know a lot of things because you were in many departments, you saw so many talks in various seminars, etc. In the end, you know many directions, and then it gives you ideas.
All right, Pierre, so for this next session, I have prepared a little game for us. As you know, in machine learning, we have tons of publications, and there's so many publications that it's difficult for authors to get noticed. So some of them have the idea to put some quirky or weird or funny titles, containing puns sometimes. And I've selected some of them, to which I've added some that I've created myself, which do not exist. So I'm going to give you a list of 10 titles, and for each of them, you're going to give me your opinion whether or not this title exists, or if I made it up. Are you ready?
Yeah.
Okay, let's get started. The first one is the following. Nice perfume. How long did you marinate in it? Multimodal sarcasm explanation.
No.
It does exist.
Okay.
It was published in AAAI. The next one is Moody Mad Eye, an attention tool for the detection of hate speech.
Okay, I would say yes.
Oh, that's pretty good. It does not exist.
Okay.
It could. So if anybody's watching this video and you're working on detection tool for hate speech, well, that's an idea.
It might exist soon.
The next one is, we used neural networks to detect clickbaits. You won't believe what happened next.
Okay, yes.
Yes, it does exist. It was in Advances in Information Retrieval. Oh, good job. This one has really surprised me. The next one is, what makes Paris look like Paris?
Okay, I would say no, so yes.
Yes, it does exist.
Okay.
So it's in SIGGRAPH, so it's one of those computer graphics paper. BERT has a mouth and it must speak. BERT as a Markov random field language model.
Okay, to be honest, it could be yes, so I would say no.
It exists.
Okay.
It's not published, but it's on archive, and I think it has a pretty high number of citations.
Okay.
Next one. The isotonic regression drink finally goes smooth.
Yes.
No, it doesn't.
Oh, well
But
done.
no, does not exist. The next one is learning to learn by gradient descent by gradient descent. Twice.
Yes.
Yes, it does exist. It was in NeurIPS. So
And
of course
it makes
it's
sense.
like
It makes sense.
it makes sense actually. Yeah, it's a smart title. Dense neural networks are ... dense.
Yes.
No, it doesn't.
Okay.
I made it up.
Okay.
I think I'm quite good at this game of making like fake titles. The next one is Black Mamba, a lethal data poisoning approach for state space models.
Yes.
No.
Okay.
It does not exist.
I think I have like a 0 score for now, maybe 2 out of 10.
No, I think I was not too bad doing that. I had a lot of fun making that yesterday.
Yes, obviously.
And the last one is called Fixing a Broken Elbow, ELBO.
Yes, I know this paper actually. It exists. Yeah, I mean, I work on variational inference, so I know the
So of
elbow.
course,
I heard
yeah.
this paper.
One topic I would like to mention, so Pierre, he has the reputation to give like always amazing presentations and courses which are extremely clear and enlightening. And he came, for example, to the Machine Learning Summer School and gave a very enlightening presentation. And I would like to ask you if you have tips to make clear presentations.
I don't always give clear presentations. Younger, I was extremely scared by the fact that some people in the room who might be specialists of the topic might find it easy, and so that I had to give as much material as possible. And then in the end, you end up talking to these specialists who are not impressed anyway, because like these people were just actually super good. And the rest of the audience does not get a single thing actually out of your talk. Actually, they don't get any information from it. Things I realized, or I was taught by other people. First, I remember exactly a sentence by Lucien Birger. I was attending a conference, Lucien Birger was there, and he told me 1 hour, 8 slides at most, otherwise it's too much information. So obviously it's a little extreme, but
so how long was the talk?
1 hour.
1 hour,
I must say it was 15 years ago, and in this case it was handwritten slides, so they contain maybe a little more information than, PDF slides or whatever. But still, I always try to keep this in mind. You write the overview of your slides, you prepare your slides, and then you have to remove half if you want people to be able to understand it, because you always tend to put too much, and then actually you have to remove stuff. You don't have to say everything about your paper in the slides. Second point, if you improve a rate of convergence in a very specific algorithm that computes a very specific estimator in a very specific model, half of the audience in the room are PhD students who don't know that the rate has to be improved, but they don't even know this algorithm and they don't even know this model. So if you start by explaining the model and then the state of the art, and it takes half of the talk, these people will already learn something. And then you can use the second half of your talk to give your results. But if you skip this, then actually, once again, you only talk to the specialists. And the people who don't know what your talk is about will not know what your talk is about at the end of your talk either. I really insist on the fact that, from what I learned at least, not to overload people with too much information means that you have to cut slides, to remove some things that you want to say, to remove equations, to remove text. And it has to hurt. If you still feel comfortable with what you have in your slide, it means that it's too much. Just imagine that there are two people. One of them should, be angry after the other. There is too much material on your slide. And you should be the one to say, no, it hurts to remove this, but I have to do it because otherwise it would not be understandable at all.
For the viewers, I know that some of you are in the beginning of this machine learning journey. What would be the roadmap to get to machine learning, engineering, or even research for aspiring researchers or engineers or data scientists among us? How should we learn machine learning?
Really depends on what you want to do. Because the point is that more and more people don't need to come to universities to learn machine learning. They can learn to code, and then actually there are very good libraries available, open source, and there are amazing lectures on the web. People can learn to use these tools quite easily, I would say. That's one way, and absolutely, actually, it's nice that we have all these resources, super useful, etc. But the point is, it's not the same thing if you just want to learn how to use a few existing methods, or if you want to learn to develop new machine learning algorithms, if you want to do research, actually. And in this case, if you want to learn machine learning from scratch, but to become a researcher in the field, well, sorry if I'm a little old school, but I think that you have to eat some maths and theoretical computer science and some to learn to code, etc. You really have to go through the basics. And there's a reason why in high school we teach the basics of maths, and then now, of course, it was not the case a long time ago, but now we try also to teach the basics of computer science. It's because you need these basics to train your brain to think about all the problems. If you don't understand differential calculus, then at some point, I assume that you will have problems when you try to train neural networks, right? For young people who want to become machine learning researchers, so I would like to give thoughts of support, right? If you want to do this, then good luck, do it. And if you prefer theory or if you prefer applications, etc., choose something that you're excited in and do it, actually.
Pierre, thank you very much for joining us. And
thank you.
It was a great pleasure. Thank you so much for watching. If you enjoyed this video, don't forget to give it a thumbs up, subscribe, hit the bell icon to get notified of the next video. I try to upload content every week or at least every 2 weeks, so stay tuned. Thanks again so much for watching. I wish you a wonderful week, and I'll see you in the next video. Cheers.